Hey, how's it going guys? My name's Daniel, aka HashLips, and welcome back to my channel where I teach you how to code. Today we're going to be taking a look at how to hide the metadata from snipers. You see, when it comes to NFT smart contracts, everything is public. And as soon as you have set a token URI, snipers, so-called hackers, can basically look into the future of your NFT drops, and they can wait for the perfect time to mint those rares. We are going to show you today a solution that you can implement on the start of your NFT collection before you have revealed your collection to the world. Later on in a part 2 video series, I'm going to be showing you how to implement the same solution, but if you have already revealed and you want to mix up the data so that it becomes unsnipeable. As a prerequisite to this course, you will already need to have a contract deployed on the blockchain. If you don't know how to do this and you really want to know and find out how to create NFT collections, please go to my YouTube channel and watch the How to Create an NFT Collection, the Ultimate Guide. You should then already have Pinata set up with your hidden metadata and your revealed metadata pieces. When you look at that video, you'll understand what this means. For those people who are purely looking at this video for a solution, I take it that you already have your smart contract ready, and the only condition is that you shouldn't have revealed the metadata. Next, we are going to make use of the new library that was written by Marco, a remarkable dev in our community. Most of you know the GitHub repo as HashLips, and now I present to you the HashLips Labs. This is an organization that I started along with the dev, and this is Marco. I've introduced Marco as a remarkable dev, and indeed he is. He's managed to come up with a solution to make metadata unsnipeable, getting back at those snipers for trying to get those really rare NFTs. So a big thank you goes out to Marco. I also want to say that Marco will be starting his own YouTube channel where we will be discussing the repos that we work on together in this organization. We will also do exciting things like rewriting the HashLips art engine so that it can be plug and play and all sorts of good things. The repo that I want you guys to focus on is this one over here. Safe NFT Metadata Provider. We will get back to this in just a second. But before we can use the repo, we need to subscribe to a few different things. This brings us to our first subscription. This is Infura, and you can go to infura.io and get yourself subscribed. Infura is a blockchain node or a provider that gives you access to the blockchain, reading from the contracts and writing to them. The reason why you would need a subscription is because the GitHub package is going to utilize this connection to read the total supply of the live contract. It does it in a very effective way with a caching mechanism. So even if you subscribe now, you can still be good using the free plan. Let's go through the subscription process. I'm going to click on sign up and then enter my email and password over there. It is a quick sign up process providing an email, a password, and then verifying it on your email itself. Once you get into Infura, you'll be presented with a dashboard like this. You will need to click here on a new project. Then we're going to select the blockchain and we're going to click on Ethereum. Then I'm going to enter a name. For now, I'm just going to say test metadata D, so TMD would be fine. Click on create, and this will give us a project ID and a project secret. The reason why I'm showing you guys this is for educational purposes, but never really share this project ID. Even these endpoints, you shouldn't really be sharing, because these endpoints will allow you to kind of make requests on your behalf. There's a lot of information on this page, but the only endpoint that you need to worry about is this HTTPS endpoint. This will be the endpoint that gives us access through our project to interact with the blockchain. So keep that in mind. We will get back to this page soon enough. So maybe just keep this open for just a second. Next, we're going to go back to the repo. Now, this is not the HashLips repo. Remember, this is the HashLips repo, but now we're going to refer to the HashLips-Lab repo. We are still going to be doing awesome stuff here, but the repos on the HashLips Labs are going to be refined repos that we're going to maintain on a regular basis. The repo that we are going to be focusing on, like I said, is the Safe NFT metadata provider. So click on that so we can open it up here. You can also alternatively go to the link right here at the top. It's always a good idea to scroll down and use the release versions. But seeing that we are going to use something that's in the README file, we're going to scroll all the way down until you see Deploy to DigitalOcean. If you do not have a DigitalOcean account already, we have a great solution. You can click on this link and use the referral link, because this gives back to the dev who wrote the code, Marco. I'm going to go and support Marco as well by registering via this link. And if you do that, you actually get $100 credit to use on DigitalOcean. So I need to go and register because this is where we're going to deploy the code from. Something important to note is that the app will actually run on DigitalOcean server, while it will actually be deployed from GitHub. So register, and I'm going to register with Google over here. So I just registered with Google, and I did have to fill in my card details. This means that DigitalOcean just wants to verify that it's me, and they're probably going to take a small payment and then pay it back to me within a week. If you've made it this far, it means that you are serious on your NFT project, because hiding the metadata, even though it's a few extra steps, it's well worth it for the community. I also want to mention to just always make sure, even if you're watching this video 2 or 3 years from now, that the link stays relatively the same. We always want you to be secure, but seeing that this is now a new video, it should be all perfect. The first thing that we need to do is look at some storage. We now need to take our IPFS data and replicate it on an S3 bucket. I think it's well worth mentioning that by this time you should have already uploaded your metadata, the hidden ones as well as the unhidden ones on IPFS. This is because indeed we are going to upload all this content on a centralized server. But once our process is done and your community has minted out all the NFTs, it's always good to switch it over to the proper IPFS decentral link. So in the meantime, get your folder ready with your hidden metadata as well as the images and metadata, the JSON files, because we are going to be uploading it on an S3 bucket. So jumping back to DigitalOcean, I'm going to go ahead and click on the Explore Control Panel. The Control Panel gives us a better view of the services that DigitalOcean provides. The thing that we are looking for first is these spaces. And the reason why is because we need some kind of storage mechanism to store our data that will be served by the server. This is almost exactly the same as an S3 bucket on Amazon. In DigitalOcean, they just refer to them as spaces. So let's go ahead and create a new space. I'm going to click on Create a New Space, and then I'm going to choose Frankfurt. I think the European networks and data centers are pretty good to use. So I'm going to stick with this one, leave everything as default, and then choose a name. I'm going to choose the name TMD. And that's just going to be basically for my test metadata. So it says already taken. So I'm going to say test MD. And that's pretty cool. It is available. So now that I have this, I'm just going to leave it on the first project and say create space. You will be presented with a screen like this. Now, you can directly upload the files that I'm going to show you what to upload directly on the web interface by clicking on Upload Files. Keep in mind that you can only upload files less than 5 gigabytes. Therefore, we're going to rather create an API access key that will give us access to our space, and then through Cyberduck, we can then go ahead and upload larger files. In order to create a spaces access key, go down to the API section right below the billing section. Keep in mind you do not want to create a personal access key. You want to create a spaces access key. So scroll down and click on Generate New Key. Once you've done this, you can give the key a name. I'm going to call it my underscore and then TMD key. And that's fine. This will save it, and now I've generated a spaces key. Keep in mind, these are secret keys and you should not, never, ever share this with anyone. If you do, people will be able to mess around with your bucket, upload and remove data. So keep these, please, secret. And it doesn't help you going and trying these out after this video, because I will make sure to delete mine. It's important to note that at this point, if you leave the page, that you will not see the secret key again. So copy it and write it down so that you can use it. The next piece of program that we'll need is some way to create a connection to actually transfer our existing data. We are going to use Cyberduck because it's open source. So we are going to click on download and then install it. I already have Cyberduck open, so I'm going to open it up and it looks like this. So on Cyberduck, what you want to do is actually click there and open a new connection. Please remember to select Amazon S3 here at the top, and then we need to import our keys. So our secret key we already have copied, so I'm going to paste it in there. Then we're going to need our access key, which is this one. Going to copy that, go to Cyberduck and paste it in. Then I need to get the service URL. So where can we find that? Well, we can go to the spaces section. Once you get to the spaces, you can see that there's our test MD. If we click on that, we can now get the URL from it here. Please omit the beginning part because we really want a general connection to all of our spaces. If we go back to Cyberduck, you need to make sure that you're on Amazon S3. Then for the server, we're going to replace it with our URI. Make sure the access key is in there, as well as our secret. And then once everything is ready, click on Connect. There we go. Our connection is now set. And as you can see, our test MD is showing up here as our bookmark. So now we can actually go in here by double clicking on it, and up here you can see we're definitely in this directory. Now we can go ahead and upload our files. Next, open your folder where all your data is saved. It's a good decision to make a duplicate of this folder because we are going to change it quite a bit. Firstly, I'm going to create a new folder and call it Hidden. After that, I'm going to take the contents of my hidden image as well as the hidden.json. Then I can remove these two folders. I can now see that in the hidden directory, there are two files, hidden.json and hidden.png. The next change is to do with the images. We need to call these assets. Once these are called assets and the metadata folder is there, which is fine, in our assets we just have our PNGs. We only have 12 NFTs, so there's 12 images. And then in the metadata, we've got the JSON files. Seeing that we also need the ABI for our program to communicate through Infura with the blockchain, we're going to need to upload this too. So what I'm going to do is maybe duplicate a JSON file over here, and then I'm going to rename this as our ABI.json. Where am I going to get the ABI from? Well, you can go to the contract and then go to contract. After it's verified, you should actually be able to scroll down, and here's all the ABI data. So copy this, then go back to where we were. Now we can actually edit the ABI. So I'm going to simply edit this in a text file. So I'm going to select everything, paste my ABI and save it. Then I can close this file, and now I've got my ABI.json, my assets, my hidden folder, and the metadata. Now I can go ahead and select everything and simply drag it over. It's going to ask me for my secret access key again, so that's why it's a good idea to sometimes save it. I can quickly jump back and copy it because I haven't closed the page. But it's a good idea to save this in your keychain, but I'm going to delete it, so that's why I'm doing this again. I'm going to say login, and there my data is being uploaded. We now have all of our files and folders uploaded to our space. Now it's time to deploy the application from GitHub. Go back to GitHub HashLips Lab, go to the Safe NFT metadata provider, and if you scroll down all the way to the bottom, now you can simply click on Deploy to DigitalOcean. So now DigitalOcean should open, and we will see a configuration page. So this is where we're going to fill out a few details that we have gathered along the way. All you need to know is that for the top environment variable, we're going to leave this as prod, meaning this is now production. This false variable is very interesting. Remember, we are only going to deploy this as soon as you are ready to reveal the metadata. In that case, this is set to false by default, but we need to set this to true. This means that the server will only allow the metadata to be shown for the numbers that already have been minted. That is good because let's say your collection hasn't minted out all of the total supply, this will actually keep the rest hidden as they mint. But remember, you're only going to do this before you reveal to get the actual revealed URI. The rest of the fields are quite explanatory. For instance, we have the default website. So if you have a minting site or some site that you want to redirect the user to, if they don't get the metadata, you can input it here. Then we get the max supply, and this should be the same as in the contract. We then get the extension of your assets. You can change this to any other format, as long as it's the same format as your assets. For instance, we also get the hidden asset extension, which is currently set as GIF. I'm going to change that to PNG as well. The metadata template is something that we're not going to change now, but in part 2 where I show you how to upload metadata for if you already revealed and some snipers is busy sniping the data. We can leave that null at the moment. The cache expiration setting is in seconds, and this just means the frequency that the program will be communicating with the blockchain. So 600 seconds, which is about 10 minutes, is perfectly fine. We have our region, which is the Frankfurt region, and then we also have this endpoint. Where do we get this endpoint from? Well, if we go back, this is the exact one that we get. Please remember to append the HTTPS like it's shown over here. For the access key as well as the access secret, we already have that information. So go ahead and copy this because this is the spaces information. So we're going to input our key over there. Then we can go and grab our secret. Hopefully you have saved this. Otherwise you will have to redo this whole section. So let's go back and let's go paste our secret key. For the bucket name, you will need to get the bucket, and this is our bucket name. test MD. So I can just go back and write test MD. That is perfect. For the prefix, this kind of empty field, this is if you have subfolders that you want to point to. We don't, so we're going to leave it as it is. The next bit of information that we'll need is actually the contract. So copy the contract address, then go back, and this is where you'll input it. Now we need the last piece of the puzzle. This is the Infura main link. And if you remember, we did this way in the beginning. So copy this HTTPS link, go back, and then go and replace this with yours. And we should be all set. This one is just red because of Grammarly. So next, we can simply click on this button. The last two steps is for us to choose a name. So I'm just going to call this TMD, maybe dash app. And let's see if that's available. And it looks like it is. Then let's go and select our region. We're going to choose Frankfurt again, and then click on next. You will get to this page where you can select a plan. Now you can select the basic plan, it should be fine. But if you need more processing power, you can always update it afterwards. Remember, this is only for the duration of your mint cycle. After you are done with it, it's preferable to switch back to IPFS. Now, if I go down, by default it selects the $10 one. You can just select the $5 one. And we can just go and launch a basic app. And there we go. This is perfect. Our app is being built, and it will take a while for the Docker images to get up and running. But once it's running, we will be able to query our metadata from our app server, and it will be unsnipeable. Now that our app is up and running, we should be able to see our metadata. I do, however, want to point something out, but let's go through the process. This is your endpoint, and this is the endpoint that you're going to use to go and query the metadata. But you can't call it just like this. If you go to this link, it will point you to that example domain that you have set up. This is so that hackers, if they want to go and mess around with the app on different endpoints, it will simply redirect them to the example domain. If you do want to access the metadata, however, you need to go and change the URI and append the metadata attribute with a / and then query the JSON. So for instance, if we would like to check the one.json token, we can query it, and then it should give us the metadata for that token, or give us the revealed metadata, so either the hidden or the revealed. But as you can see, there's an error, and I left this in the video for a specific reason. That reason is because when I was setting up the app, I wasn't really paying attention to my Infura link. You see, the endpoints point to the main network, but I am busy testing on the Rinkeby network. So I will need to change this to Rinkeby and then recopy this link. Now, before I can change this link in our app, there's something that we'll need to do. This is the live app running, and in order to change any environmental variables, we'll need to go to the settings page, go to the components up here, scroll down until you find the environmental variables, click on edit, and here you can set them. But as you remember, some of them are encrypted to protect the endpoints. So in order to update this provider endpoint here at the bottom, we will actually need to paste the value there, go ahead and copy its key, remove it, and then only add it. So now we can go ahead and say save. This is now pointing to Rinkeby, and hopefully once everything has been set up and the build has taken place, we should now be seeing proper metadata coming from this endpoint. The app is now live again, So let's reiterate the step. Go and copy the endpoint, paste it in here, make sure the metadata is appended, and let's test it out. If I query this, it comes back with the actual metadata, and it shows the number 1. And this is great news, because if we go to the contract, number 1 indeed already has been minted. Now it comes down to the true test. If we query the second token's ID, we should not be able to retrieve it, because it hasn't been minted yet. So let's go and query it. Number 2, and indeed, it shows us the hidden metadata. No one can know what number 2's ID is and the metadata or the image that it holds. If we go back and we go to the contract and we connect our wallet to mint another one, we can see if our program picks it up. We can go down and click on mint, and we want to mint 0 for the amount, and we want to mint another one. I'm going to click on write and mint another NFT. Keep in mind that even though I can see the metadata on the server, the metadata on the contract is not yet revealed, because we still need to set the URI prefix and then reveal it on the contract as well. You have to see this app and the contract as two separate instances that you would need to keep in sync. So we'll get to that step just now. Let's imagine you are the owner of your contract and you have done this to prevent people from sniping the metadata once you reveal. Let's say your collection hasn't minted out fully yet. This method will at least prevent people from seeing even after you reveal. Before you can reveal this collection, let's go and set the URI prefix. We are going to set that to this. So copy this section without the 2.json. Go back to the contract, we're going to place it in like that, and click on write. After we have set the metadata, and make sure that it's firstly set, you're going to set revealed, and for the revealed, we're going to turn this to true. After setting the revealed to true, obviously the contract is now going to display to us this endpoint, which is now protected via our centralized server. Please keep in mind that you need to be an advanced user to understand these concepts to make sure that you're revealing this metadata through the centralized servers only for the duration of your mint. It is always and always preferred that you keep everything on a decentralized network. So after you have minted out and you are sure no one can snipe metadata anymore because all the tokens are now owned, you can go ahead and change this back to the original IPFS link which hold all the original tokens. And that data and the data on your server should be exactly the same. I hope this makes sense and I hope you find it valuable. There's a lot more that you can learn from this system from the original dev, Marco. So I will leave a link in this video description where Marco will explain more in-depth concepts when it comes to the safe metadata provider. To finish off this video, I would like to make sure that we have now 2 tokens minted. So let's go to the contract and let's check it out. Indeed, we have 2. So now if we query our data, we should be getting the proper metadata because the second token now exists and have been minted. Let's go and refresh. I'm just going to do a hard refresh. Oh, and there we go. Perfect. So we get our tokens metadata back. And the program works because if we query number 3, we still can't see what it is. One thing to note is always make sure that the spelling that I show you guys is correct. Please don't spell like me because that's why if I look at the image right now, it doesn't load. Because if I go and look at my little space, I've spelled assets completely wrong. So let's go and change this out to assets and let's rename it. Now that it renamed, and keep in mind, if you rename something on the space, it's going to have to rename through all those files. So it's best to get the right spelling before you upload it to the space. However, I renamed my files, or at least my folder, to assets. So now, if I go back and I can see that there's my image and I click on it, it should load. And that is it, guys. I really hope you enjoyed this video and that it makes sense on how to kind of hide the metadata from those snipers out there. I will make a new video about how you can do the same kind of process, but if you already have revealed your metadata and snipers got a hold of that precious IPFS link. There's a situation where we can take that IPFS link with all the data and just mix up the rest of the NFTs that still needs to be minted. Then we can re-upload that to IPFS and do this solution, and then later on you can swap it out again. Like I said, thank you for always watching and supporting my videos. I really appreciate you guys. Leave this video a like and a comment because I really look at them and make some suggestions what you would like to see next. I also would like you to go ahead and subscribe to my main channel, which is this one, as well as my new channel called HashLips 9to5, where I have some fun and make some projects, talk about reviews, and in general, just do some artistic things. So, till next time, have an amazing day. Cheers for now.